Okay, so complementary angles add up to 90 degrees. Supplementary angles add up to 180. Now I remember this because C comes first in the alphabet, which means it's smaller. S comes second, so it's the larger of the two. So to find the complementary angle, we do 90 minus 58, and that should give us 32. So our answer is B. Okay, an obtuse angled triangle has, the first one says 3 acute angles. Well, if it has 3 acute angles, it doesn't have any obtuse angles. So we can probably cross out that one. The next one, 3 angles of equal size. Well, we know what that's called. If any triangle has 3 equal sides or 3 equal angles, it's a equilateral triangle. So that can't be the name. And we can also cross out E. That says all 3 sides are of equal size. The next one, 1 angle greater than 90 degrees. Well, an obtuse angle is greater than 90 degrees by definition. So I'm thinking it's probably that one. D, the hypotenuse as the longest side. Well, again, we know that a triangle with a hypotenuse is called a right angle triangle. So it's not going to be that one. So it must be C. Okay, which statement is not true of a regular polygon? So a regular polygon is a 3-sided shape, or it could have more than 3 sides, where all sides and all angles are equal and all sides are straight. So by this definition, we can cross off A and D because both of those are true. Secondly, we know that the sum of all internal angles can be found by splitting the polygon into triangles because we did this in our investigation task earlier in the term. So it's out of the last two. So the sum of all exterior angles is 360 degrees, or the sum of all exterior angles is 180 degrees. So if we're not sure about this, let's test it. So let's choose a regular polygon, say a square. So all angles in a square are 90 degrees. So let's have a look at what the exterior angles should be. Well, we know that this angle here is supplementary or adds up to 90 degrees. So my exterior angle for each of these must be 90. 90 plus 90 is 180. So my exterior angles would be 90 times 4, which is 360. So I now know that B is true. So E must be false. The sum of all exterior angles is not 180 degrees. So a quadrilateral, so a 4-sided shape with one pair of opposite sides parallel, so it has to have one pair of sides parallel, is called a, well, it can't be a pentagon, that has 5 sides, so let's cross it out. Triangle only has 3. What else? Okay, so they're the ones without 4 sides. So now a trapezium, well, a trapezium looks something like this, and it does have 2 sides parallel, and those sides are opposite each other. So it might be that one. But what about a kite? So a kite has some equal sides, but none of these are parallel. They all would meet with each other if we extended them. So it can't be a kite. Lastly, a rectangle. Well, a rectangle does have parallel sides, but it has 2 sets of pairs, not just one. So it can't be a rectangle. So our answer is C. Okay, question 7. We have to identify what the figure below is. So let's see, is it a rectangle? Well, I know a rectangle has all straight sides like this, so it's definitely not a rectangle. What's a polygon? So a polygon is a shape with 3 or more sides that are all straight. So it could be a pentagon, a hexagon, octagon, etc. So this shape has 4 sides, but one of them over here is curved. So it's true that this shape is not a polygon. But let's just double check. So quadrilateral, well, that's a 4-sided shape, but again, a quadrilateral, whether a kite or a trapezium or rectangle, have straight sides. Last one, rhombus. Well, a rhombus again is a four-sided shape and it's just a tilted square. So it has four sides that are all straight. It doesn't look like that. And a concave polygon. Well, a concave polygon has to have straight sides because it's a polygon. And it actually looks something like this, where two of the sides point inwards. So it can't be any of those three. So our final answer is B, not a polygon at all. Okay, which angles are not equal? Vertically opposite angles. Well, let's have a look at what they look like. So these are vertically opposite angles. And we know for a fact that these two will be the same and these two will be the same. So vertically opposite angles are equal, so let's cross that out. Corresponding angles. Corresponding angles are the angles that make an F shape on parallel lines. Now we know that they're also equal, so it can't be that one. Alternate angles make a Z shape. Again, they're equal. Now co-interior angles, well, they're the ones that make a C shape. Now they have to add up to 180 degrees. So they are not equal. So I think that D is our answer. But let's say the last one, the angles inside a regular hexagon. Well, if we think about a hexagon, so it has 6 sides which are all the same length and 6 angles that are all equal. So it can't be E. Our answer is C, co-interior angles. Okay, so here we have a triangle and try to figure out W. So the first thing we know is that the angle sum of a triangle is 180 degrees. So we have 180 degrees equals. Well, we know this is isosceles, so this little angle in the corner should be W as well. So 180 degrees equals W plus 50. So let's simplify this expression a little bit more. So 180 equals, well, there's two W's, so let's just put that in, plus 50. All right, now let's work with our equation to rearrange. So to get rid of the 50, subtract from both sides. 180 minus 50 is 130 equals 2W. The last thing we have to do is divide both sides by 2 because they'll cancel. So we'll get W equals, and 130 divided by 2 is 75 degrees. Okay, so what we have here is a parallelogram. So we can see here that opposite sides are parallel. So if I just identify this C, or co-interior angle, we see that X plus 64 has to equal 180 degrees. Now I just solve this equation. So I minus 64 from both sides. And what I'm going to end up with is X equals 116 degrees. Now the next thing that we could notice is that we have another set of parallel lines. And we see another C. So we see that Y plus 64 also has to equal 180 degrees. But didn't I just do this before? So let's do it again. Minus 64, and Y as well is going to end up with 116 degrees. Okay, so what we have here is two parallel lines and a triangle. So let's start by identifying if we have any co-interior, corresponding, or alternate angles. Now there's a few here, but let's just identify one. So I see this Z, and I know it's alternate. So these two angles must be equal. And now we have two angles of a triangle that we know. So we have 42 plus 90 plus W equals 180 degrees. So let's simplify this. So 42 plus 90 is 132 plus W must equal 180 degrees. So all we have left to do is subtract 132 from both sides. And we'll be left with W equals, well, 180 minus 132 is 48 degrees. So W must be 48. And you can double check this by adding 48, 42 and 90 and you should get 180. Okay, so we can attempt this question in a number of ways, but do what's most obvious to you. So what we learnt is the external angle theorem. So we know that the external angle must be equal to the sum of the two opposite interior angles of a triangle. So that means 138 must equal m plus 90. And all we have to do is rearrange. So we subtract 90 from both sides, and we're left with m equals 138 minus 90 is 48 degrees. Okay, so here we have a set of parallel lines, and we can see a C shape here. So we have co-interior angles that must add up to 180 degrees. So let's go ahead and put that into an equation. So we know that C plus 12 plus 40 equals 180 degrees. So now I can just simplify this. So I have C plus 52 equals 180 degrees. So all we have left is subtract the 52 from both sides to get rid of it, and we get left with C equals 128 degrees. Okay, so let's start from the top. So I know that 2x and 130 lie in a straight line. So 2x plus 130 have to add up to 180 degrees. So let's go ahead and solve this. Subtract 130 from both sides. We will have 2x equals 50, but this is 2x, we just want 1x. So divide both sides by 2. We will get x equals, and 50 divided by 2 is 25. Now let's start to look at y. Well, we can see here a set of alternate angles, the 2x and this angle right here. So I know that this angle in blue is 2x, and I also know that it lies on a straight line with my y. So we have 2x plus y again has to equal 180, and I know that 2x was, what's up here, 50 degrees. So 50 plus y equals 180. So let's solve for y minus 50 from both sides. Well, y must be 130 degrees. Okay, so this question is similar to a question before, where we use exterior angles of a triangle to find out the interior angle. So let's start with what we know. So we can see here that we have a straight line, and straight lines add up to 180 degrees. So we have 180 equals 129, and let's label this side M. So now we rearrange like normal, subtract 129 from both sides, and we get left with M equals, well, 180 minus 129 is 51 degrees. Now we also know that this exterior angle must equal the opposite interior angle. So M plus X must equal 138 degrees. But we know what M is, so we have 51 plus X equals 138. So all we have left to do is subtract the 51 from both sides. So we have X equals, and 138 minus 51 is 87 degrees. So X must be 87 degrees. Okay, so here we have the sum of a quadrilateral, and we know that the sum of quadrilateral is 360 degrees. So we have 360 equals 2g plus g plus 20 plus 3g minus 6 plus 40. So now let's simplify the right-hand side. So we still have 360 degrees. We have 2g plus 1g plus 3g, which is 6g, plus, well, 20 minus 6 is 14, plus 40 is 54. Now all we do is rearrange. So let's take out that 54 from both sides, and 360 minus 54 equals 306. So we'll get 306 equals 6g, because these 54s will cancel. And now all is left is we have to know that 6g is really 6 times g. So the opposite of times is divide. So we divide both sides by 6. 306 divided by 6 equals 51. So G must be 51 degrees. Okay, so here we have a trapezium. It has two parallel sides. And this 110 is kind of excessive information. We don't really need it because we can see straight away that we have a Z. And alternate angles, or Z angles, are equal. So A equals 30 degrees because alternate angles are equal. Okay, so here we have a kite. So what we notice straight away is that this X and this 105 have to be the same because they're both between the same type of lines. Secondly, we know that kites or quadrilaterals have to add up to 360 degrees. So 360 has to equal X plus 85 plus 105 plus Y. Now we know what X is, so we can replace that with the 105. So we have 105 plus 85 plus 105 plus Y. Now let's simplify the right hand side. So 105 times 2 plus 85 is 295. And our last step is to get rid of this 295 from both sides. 360 minus 295 is 65. So Y must be 65 degrees. Now you need to be careful not to assume that this 85 and this Y are the same, because we see that the 85 is between two lines with only one arrow, but the Y is between two lines that have two markings on them, so they're different. Alright girls, you should know this by now. Okay, so we have the angle sum of a polygon is S equals 180 times N minus 2. Alright, so our number of sides is 12, so we have 180 times, well 12 minus 2 is just 10. So our sum is 180 times 10 is 1,800. So this is the whole polygon, but we only want one angle. So we know there's 12 sides and we just want one. So we divide by 12. So we have 1,800 divided by 12. So one angle, let's just call it X, equals 150 degrees. Okay, so the following triangles are congruent, and we see here that we have two angles that are the same. We have a side that's the same, and we have another angle that's the same. So we could say angle U is equal to angle X. We have US is equal to side XV, and we also have angle S is equal to angle V. So therefore, by angle, angle, side, triangle UST is congruent to triangle XVW. And just make sure that when you're writing out the congruent statement, that the sides that are congruent and the angles that are congruent match up. Okay, so this question was a little bit ambiguous. So as long as you justified your answer properly, we gave you the marks. So let's say the case that they are similar. So here, let's look at the sides that are the same. Okay, so we know that Kn, well, has to equal Kn, right, because they're common. Then we know that Pn equals Nm. And finally, that Pk equals Km. So therefore, side, 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 you could have put congruent. Now, there was another reason why we gave a different answer, just in case, because it is quite ambiguous. So let's rotate one of the triangles around. So let's leave the P and K the same. And let's put the markings here. Now, let's rotate the other triangle the same. So be careful to keep all the letters in place. So I've just rotated it clockwise. So my N will now be down the bottom, my M will be here, and my K will be on the right hand side. So let's see, if I rotate it, well, between N and M we have our 2 lines, and between K and M we have 1 line. So now as you can see, if you look a little bit more clearly, that these sides are not in the same position. So if they're not in the same position, that tends to mean that they're not congruent. So if you did it this way, we also gave you a mark. So if you said PN does not equal MK, like they should, and KP does not equal MN, then you could have said not congruent. And we also would have given you the marks for that. Okay, so let's see why these angles are similar. All right, so let's identify the obvious. So first, they have an angle that's the same. So we know that. And we also look at the sides. So this is the information we have. So the 8 and the 12 and the 9 and the 6. So for angles to be similar, their sides must be proportionate. So let's see, 6 over 9. If I simplify and divide both of those by 3, I'll get 2/3. And 8 over 12. Well, if I simplify that, divide 8 and 12 both by 4, I'll get 2 over 3. So I know the sides, 2 sides are proportionate, and we have the in-between angle the same. So they're similar because of the rule side, angle, side. Now, if it was easy for you, you could label all the vertices A, B, C, D, E, F, and match them up. So the next thing we've got to do is find the value of y. So let's write our equation with our matching sides. So we have y over, well, y is proportionate to this 5 here. So we have y over 5 equals, now it doesn't matter which side you chose, either the 12 or the 9 to work with, but just make sure that you choose the matching sides on the other one. So we have 9 over 5 equals 9, so stick with the bigger triangle first, over, and the matching side to the 9 is, like we said, the 6. So then let's get rid of the 5 on both sides. They will cancel there, so we'll get y equals, well, 9 times 5 is 45 over 6. And if you're good at long division, you can do 6 goes into 45, put some extra zeros in there. Well, 6 goes into 45 7 times, remainder 3. Put our decimal, 6 goes into 30 5 times. So y equals 7.5, and you're done. Okay, so this question is quite tricky because we have to explain our answer. And in doing this, we can do whatever we want, really. So let's just pretend that we only know one angle and see if we can figure out the rest. So let's just pretend that we know that this angle here is 60. Well, we also then know that this angle here must be 60 degrees. We also know that 60 plus 60 plus this unknown angle here, B, and, well, opposite must be B as well. So we'll have 2B has to equal 360 degrees because this is a circle or a revolution, and revolutions add to 360. So now let's simplify this. So we have 120 plus 2B equals 360. Okay, so now let's rearrange. So we want to get B by itself. So let's take away 120 from both sides. So we get 2B equals, well, 360 minus 120 is 240. So we know that 2B is 240, but I just want one of them. So let's divide through by 2, and we'll get B equals 120 degrees. So as we can see, I only started with knowing one angle, and now I know all of them. So B has to be 120, and this has to be 120. Now you could do the same thing with letters, or any numbers that you like, and that's just one way to show that we only need one angle to find all the angles in this diagram. Okay, so the most important part here is to figure out what this question is asking. So it says the height of a palm tree, so let's go ahead and draw our palm tree. Very nice. Alright, is found by using only a meter ruler. So this ruler is placed vertically in the shadow of the tree. So let's draw a meter ruler here and just label it as 1 meter. Okay, so we know that the shadow of the tree and the ruler stop at the same place. So just like that. So if the ruler is 20 meters from the tree, so from here to here is 20 meters, and the ruler to the end of its shadow is 4 meters, so let's put that there and put a little dash here to know that they're separate. And let's just draw in our triangle and our right angles. Okay, so we need to find the height of the tree, so we can label that in as x. Okay, so now what we can do is we see our two separate triangles a little bit more clearly. So one has 4 and 1 as its sides, and the other one, again, it's not just 20 or 4, but it's the whole length here, which is 20 plus 4, 24. So we know that this side is 24, and we're trying to find x. So our last step is to just do our equation as usual. So which sides match? So the x and the 1 go together, and then we stay with the x triangle, so 24 over 4. Now we get rid of the 1, so x equals 1 times 24 over 4. Well, 1 times 24 is just 24, and 24 divided by 4 is just 6. And make sure we put our meters in. Okay, so the key word here is parallel. So we know that these two lines are parallel, which makes our triangle similar. And we can see the angles that must be congruent because they're corresponding, and the angle that's equal up the top. So let's go ahead and draw our triangles. So we know the small one has side length 4, and the base, which is what we're trying to find, is just given by x. We also have our tall triangle, or the larger one. Now its base is given by 18, and its side length is the whole length here, which is not just 4 or 6, but it's actually 4 plus 6, which is 10. So we can go ahead and add that in. Now our next step is to put our equation and match our sides. So we have x over 18 equals, so we started with the x, so let's keep with that triangle, 4 over 10. Now we get rid of the 18 by multiplying, so we have x equals 18 times 4 over 10. Now we can simplify that, so 18 times 4 is 72, divided by 10, 72 divided by 10 is just 7.2, and be sure you put your meter symbol in there, and then you're done.